in this lesson, I'm going to go over some of the problems from the Chapter 12 worksheet. So these are the two main equations that you will need to know. The combined gas law and then the ideal gas law. So the main difference between these two equations is that the ideal gas law right here has N in it. And N, if you remember from the lecture, N represents moles. Okay, so anything with grams or moles in it, you're going to use the PV equals nRT. Because in the combined gas law right here, it does not have moles in it. Okay, so once again, anything that has moles or grams in it, you're going to use PV equals nRT. And for this chapter, when you're doing your math problems, the temperature must be in Kelvin. Okay, it must be in Kelvin. If you do not do the math problems with your temperature in Kelvin, then you are not going to get the correct answer. All right, so let's go ahead and start with number 15 from your worksheet. All right, so let's read number 15. A volume of 2.45 liters of oxygen at a fixed temperature was collected at a pressure of 98.4 kilopascals. What volume would the oxygen occupy at a pressure of 101.7 kPa? These little numbers at the end of the problem in parentheses, those are your answers to the question. So you can always check your work to see if you're doing it right. Okay, so in number 15, does it mention anything about grams or moles? So that is a question you should always ask yourself. Okay, does it say grams or moles? If it does not have grams or moles in it, then that means you're going to use the combined gas law. So in this equation, we're going to use the P1 V1 over T1. That equals P2 V2 over T2. Okay, then also notice in the problem it says that it's at a fixed temperature. So that means that the temperature is not changing. It is remaining constant. So whatever is remaining constant, you can cross out on both sides. So that means we can cross out the temperature on both sides. So then our equation ends up being P1 V1 equals P2 V2. Now it doesn't really matter which set of numbers you want to designate as the one conditions or the two conditions, just as long as they are paired up correctly. Okay, just as long as they are paired up correctly. So as you read the problem, you probably want to go ahead and start assigning whether it is a P1 or a V1 and stuff. So for an example, what volume of 2.45 liters? So a volume of 2.45 liters. So let's just designate that as our V1. Keep reading. Okay, we know that the temperature is fixed, was collected at a pressure of 98.4. So then that corresponds with P1. Okay, then we keep reading. What volume? So that means we are solving for V2. Okay, that's the question, right? So we're solving for V2. Would occupy at a pressure of, so then that would be our P2. Okay, so then we just plug the stuff into the equation, and then we solve for the V2. All right, so let's go ahead and do that. Okay, so P1 is 98.4 kilopascals. The volume 1 is 2.45 liters. And then P2 is given to us as 101.7 kilopascals. And then V2 is what we're solving for. So you can leave it as V2, or if you want to put X there, that is perfectly fine also. All right, so let's just do the math. Solve for V2. So then to get V2 by itself, we're going to divide by 101.7 on both sides. Okay, and then those will cross out. And then you put this into your calculator. So go ahead and put that stuff into your calculator. And then if you do it correctly, then you should get this as your answer. Okay? Now you'll notice that if you look at number 16, Number 16 has the pressure in pounds per square inch. That's PSI, so it's a pressure unit. But notice that the pressure is represented in the same unit, so that's fine because those units will cross out. So you can leave it in pounds per square inch, all right? Notice here, they give you the temperature in Celsius, okay? So you have to convert the Celsius into Kelvin when you're doing your math problem, and then notice that it wants you to calculate your answer into Celsius. So you have to do the math in Kelvin, and then at the end, convert your answer back into Celsius, okay? If you just keep it in Celsius and do the equation and the math in Celsius, you're not going to get the same answer, okay? It's not going to be correct. All right, so let's go ahead and set up this next one. It says the pressure on 1 cubic foot of air at negative 15 degrees Celsius was increased from 14.7 to the 23.1. Calculate the final temperature in Celsius if the volume remained constant. So once again, ask yourself, did it say anything about grams or moles? No, it didn't. So that means we're going to use the combined gas law. P1 V1 over T1. That equals P2 V2 over T2. Notice right here it says the volume remained constant. So since the volume is constant, we can cross out the V's on both sides. Okay? So now let's go ahead and fill in the information. So let's see. The pressure on 1 cubic feet of air at this temperature. So let's say this is our T1. Okay, so that'll be T1, was increased from 14.7, so that's pounds per square inch. Once again, that's pressure. So let's say that's our P1. And then the pressure is going to increase to 23.1, so that's our P2. And then it wants us to calculate the final temperature. So that means we're solving for T2. Okay, so that means that T2 is our variable that we're solving for. All right, so let's plug in the numbers and see what this looks like. Okay, so P1 is 14.7. T1, okay, so you have to convert that temperature into Kelvin. So you have to add 273. So negative 15 plus 273, right? So then that gives you 258 Kelvin. So that's the temperature that we're going to use on the bottom over here. 258 Kelvin equals, and then the P2 is 23.1 over T2. So you can leave it as T2 or you can put an X. So this time we'll just say that's X. All right, so now what we want to do is we want to solve for X. Okay, so the easiest way to approach this is to cross multiply. Okay, so cross multiply. So then you end up getting 14.7x equals, and then go ahead and multiply those two things there. Okay, 258 plus, times 23.1, and then you're going to solve for x. Okay, so when you solve for x in the end, and you finish up your math, all right, so go ahead and finish up the math yourself. But when you solve for x, if you did it correctly, your x should equal 405. But don't forget, that's in Kelvin. Okay, that's in Kelvin. And then this question specified, it wants you to put your answer in Celsius. So then once you get the 405, convert that into Celsius by subtracting 273. Okay, and then that's how they got that answer right there. All right? Okay, there's one more type of problem that I want to do with you, and then it's on the next page. The next one I want to do with you is number 20. Okay, so now let's read this problem. Calculate the volume occupied by 3.4 moles of nitrogen at 34 degrees Celsius and 50.5 kilopascals. Okay, this is the answer that you should get. All right, so does this problem mention anything about grams or moles? Yes, it does. It has moles in it. So this time we're going to use PV equals nRT. Okay? And the question is, calculate the volume, right? Calculate the volume. So we're solving for volume in this particular problem. So that means we must have all of the other numbers. All right, so the pressure is 50.5 kPa. Solving for volume, so we can say that's X. N is in moles, 3.4. Now, R is a universal gas constant, so the R value, it's in your PowerPoint notes. You don't have to have it memorized. I'm going to put it on the test for you. So it's 8.31, and all of the units for R are L liters kPa over moles Kelvin. So since those are the units for R, that means your volume will be in liters, pressure has to be in kPa, you have to have moles, and then of course we know temperature for this chapter always has to be in Kelvin. All right? Okay, and then the last thing is temperature. So notice the temperature here is given to us in Celsius, so we have to convert that to Kelvin. So then add 273 to give us the Kelvin, and that turns out to be 307. Okay, so then we plug that in. All right, so we want to get x by itself, so go ahead and finish out your algebra to get x by itself. So that means you're going to divide 50.5 on both sides, right? Okay, and then you put that into your calculator, and then you should get this answer. Now, when you get this in your calculator, you probably get like 171 or something like that. This is just rounded to 2 sig figs, so that's why it just says 170, because it's rounded for sig figs. All right? Okay, so go ahead and work on the rest of the problems, and if you have any questions, make sure you ask me. Okay, bye.